All right, if you turn to the back of the friction notes, you'll see problems that look like this. All right, and these problems can be given to us in a couple ways. They give us free body diagrams here. So we're going to deal with those, and they want us to find the normal force, the applied force, the force of gravity, and the frictional force and the net force given our information that we have here. So this object has a mass of 10 kilograms. We're going to move it across a rough surface at constant velocity. When you see that term, it's very important to circle it, to recognize what that means. Remember that means our forces are going to be balanced. They give us the coefficient of friction in two places, actually. And we're going to use this diagram and the information we're given to determine all of these things. All right, so let's go about this systematically. I'm looking at this diagram and I'm thinking, which of these can I find first? Well, I know the friction force is mu times the normal force, but I don't know the normal force. If it's at constant velocity, I know that these two have to be equal. So this has to equal this, but I don't know this one either. So I can't figure out either one of these two. The net force is the sum of these two forces. So I can't find the net force yet because I don't know either of these two. The normal force I know equals the gravitational force. So I got to find the gravitational force first. And that's easy to do because I know that the gravitational force, Fg, equals mass times gravity. Remember, that's one of the formulas that we wrote up here. Fg equals mg. All right? So the force of gravity is mass times gravity, and the mass of this object is 10 kilograms. Gravity is 9.8. That gives me a force of gravity of 98 newtons. And since it goes downward, I'm going to write a negative 98 newtons here. And if the force of gravity is negative 98, we're sitting on a surface and not falling through, so the normal force must be the same, 98 newtons. So now what can I find next? Well, I know the frictional force is mu times the normal force. And I know both. They gave me the coefficient of friction, it's 0.2, and they gave me the normal force, 98 newtons. And if you do 98 times 0.2, you'll find that the frictional force is, I think it was 19.6 newtons. Yes. All right, so that goes in here for the frictional force, and it's negative because it's going to the left. And if we have constant velocity, acceleration is 0. That means the forces must be balanced in all directions. We have balanced forces in the y direction, and in the x direction they have to be balanced as well. Negative 19.6 over here, and it's going to be positive 19.6 to the right. Okay. Net force is just the addition of these two. 19.6 plus a negative 19.6 gives me 0. But I didn't really have to calculate that because I know the net force has to be 0 if the acceleration is 0. Also, the other way to find it is if you know that sigma F equals ma, well, sigma F is the net force. The net force is the mass times the acceleration, which they give us right here. Mass is 10, acceleration is 0, 10 times 0 is 0. A couple different ways to find that. All right, on your own, if you didn't go through these notes, I want you to look at these two problems. I want you to pause the video, and I want you to try to work these on your own before I go through it with you. Go ahead and pause the video right now. Okay. So let's go through this next one. We have a 5 kilogram object, and we're accelerating it this time. The acceleration is 2 meters per second squared. Again, they gave us the coefficient of friction. Let's see what we can find. Well, once again, I can start off with the force of gravity. That's easy enough because that's the mass, which we have, times gravity, which I know. Mass is 5, gravity is 9.8, and that gives me a force of gravity of 49 newtons? Yes. 49 newtons, and it's negative because it's going down. Negative 49. And normal force and gravity are equal. That makes normal force 49 newtons. Frictional force, I can now find the same way. They give me mu. I now know the normal force, so I can do mu times the normal force to get the force of gravity. Mu is 0.1. Normal force is 49. 0.1 times 49 gives me a frictional force 4.9 newtons. And I'm going to write it in my free body diagram as negative because it's going to the left. Now, up here, once we found the frictional force, we knew that this one was the same because it was moving at constant velocity. We do not have constant velocity anymore. And you might want to make a note to yourself. If you have acceleration, I've said this before, but I want to make sure it's clear. If you have acceleration, you must use sigma F equals ma in some way, shape, or form to solve for something. And that's what we're going to have to do to find the applied force. And let me show you how. I'm going to start with sigma F equals ma. Write that down. And the very next step is to sum the forces in the direction that I have acceleration. I know I don't have acceleration in the y direction because these are equal and it's not falling through the table or the surface that we're on. So it's not the y direction. On the left side of the equation, I'm going to sum the forces that are acting in the x direction, friction and applied force. So I'm just going to write those down first without any numbers. And now I'm going to plug in what I know. I found the frictional force. It's negative 4.9. And with sigma F equals ma, you must consider direction. It's very important. Frictional force is negative 4.9. I don't know the applied force. That's what I'm trying to find. I know the mass is 5 kilograms. I got that from here. And I know the acceleration that I want to give this box, this object, is 2 meters per second squared. So acceleration is 2. So to simplify, force applied minus 4.9 equals 10. And the last step to solve this is to add 4.9 to both sides. And that gives me an applied force 14.9 newtons. And that's what goes in here. So we found this. I know these cannot be equal. They're not because we do have some acceleration. We found the friction or the applied force, and the addition of these two gives me the net force. 14.9 plus negative 4.9 gives me a net force of positive 10 newtons. We have 10 newtons more to the right than to the left. Again, another way to find this is sigma F equals ma, and the net force is your sigma F. So if I get mass times acceleration, there's my mass, there's my acceleration. 5 times 2 is 10. So there's our second one. All right, look at the third one. If you haven't worked it yet, go ahead and pause the video now and try to work the third one. The third one, they gave us the applied force this time, which is a little bit different. I still have the mass is 4 kilograms, and we are accelerating again, 2.5 meters per second squared. I'm going to start the same way. I can always do the force of gravity by doing mass times gravity. Mass in this case is 4 kilograms, gravity is still 9.8, and that gives me force of gravity of 39.2 newtons, and since this is going down, I will make the force of gravity negative. Gravity equals the normal force, so normal force must also be 39.2 newtons. That's 2, not 3. All right, so now the question is, where do you go from here? Well, in these other two, we found the frictional force, and frictional force was mu times the normal force. Well, we have the normal force, but we don't have the coefficient of friction anymore, so we can't do that. Can't use that equation. And the only place I have left to go, since I've already used mass times gravity, only place I have left to go is sigma F equals ma. All right? Friction equals mu times the normal force is not what I'm going to be using right now. I will eventually, because I've got to find mu. I will eventually find it, but I have to have the normal force and the force of friction first to do it. I've already used Fg equals mg. I can't use this one yet. This is the only one left for me. Sigma F equals ma. All right, so again, sigma F, I will sum the forces in the x direction because that's the direction that I have acceleration. So my friction force plus my applied force equals the mass times the acceleration. And now to add numbers, I don't know the friction force, but they told me the applied force was 25 newtons. It should be plus, not equals. Plus 25 equals the mass, which is 4, times the acceleration, which is 2.5. 4 times 2.5 gives you, what was that? Gives you 10. So there's 10. That's what we simplified that to. So FF plus 25 equals 10, and then subtract 25 from both sides, minus 25, to find the frictional force. And if you do that, you'll find a frictional force of negative 15 newtons. All right, so there's my friction force. It can go right here. Negative 15. Notice again, my forces in the x direction are not balanced, and they shouldn't be because I have acceleration, unbalanced forces. Now I need to find mu. Only way to do that is with the fun equation. Friction force equals mu times the normal force. We have the normal force now, and we have the frictional force now. When we put the frictional force into this equation, I don't have to worry about the negative that's here. I'm just concerned about the magnitude of it, because mu must come out positive. And the normal force is 39.2. If we divide both sides by 39.2, you come out with a coefficient of friction of 0.38. And when you do coefficient of friction, keep 2 decimal places. Coefficient of friction is 0.38. All right, and the net force is the addition of these two forces. 25 plus negative 15 gives me 10. Once again, sigma F equals mass times acceleration. 4 times 2.5 is also 10. A couple of ways to do that. So there's a couple of example problems with friction.